Hello and welcome. Historically, there is a high-risk nature of the shipping industry due to the complex marine environment and unpredictable weather conditions, making ships vulnerable to natural disasters. Despite these challenges, there has been a trend towards upsizing, specialization, and higher speeds in the shipping industry in recent decades. However, this development does not eliminate the inherent risks at sea. Even with these developments, maritime safety remains our perpetual and significant concern. It has been universally known to the whole maritime industry that human factors account for a major part of maritime casualties. In this video, we will be discussing some real-life accidents and incidents caused by human errors and strategies to minimize these errors. Case number 1. A real-life accident. Flood tide breaks mooring lines, vessel strikes bridge. Small product tankers faced a critical situation while docked for loading due to strong tidal currents, 325 knots. The master provided with pilot information card emphasizing skilled line tending during mooring, ensuring equal tension and strong winch breaks. Next day, vessel shifted downriver for refueling, with an uneventful transit, but faced complications at the new berth due to draft considerations. Mooring line issues were detected during routine patrol. Unsuccessful attempt to use both thrusters led to 3 mooring lines on bits parting. The remaining lines on the winches experienced slipping breaks, causing them to run free and fall into the water, resulting in the vessel drifting into the river. Despite dropping anchors, the ship collided with a bridge, causing substantial damage to both the bridge and the vessel. Some of the issues we would like to address in the incidents include a small products tanker facing a critical situation during mooring due to unequal tension on mooring lines, improper docking considering tidal currents, and complications with mooring winch breaks. The vessel ultimately collided with a bridge, highlighting the importance of lessons learned. How do we address these kinds of accidents? To address these issues, a comprehensive approach to mooring operations is essential. This involves emphasizing proper tension, evaluating tidal currents, and ensuring regular equipment maintenance. Draft considerations during dock. Case number 2. Real-life incident. Symphony of errors led to collision. A Navy frigate collision in the early morning due to errors highlights maritime safety lessons. Frigate traveling at 17 knots in darkness with AIS in receive-only mode, limiting its own information transmission. The bridge team, preoccupied with portside vessels, fails to assess an unidentified object on starboard and assumes it's stationary onshore. Departing tanker faces communication challenges, unaware of the frigate's identity, exacerbated by the absence of AIS signals. Tanker pilot struggles to obtain frigate information, miscommunication with VTS, delayed awareness, attempts to signal with Eldish lamp. Collision occurs due to a lack of clear communication, causing substantial damage. This case involved a collision between a Navy frigate and a tanker, primarily due to limited AIS transmission, communication challenges, reliance on visual signals, and assumptions about the vessel's status. Effective communication and situational awareness were lacking. What can we do not to repeat these kinds of incidents? Enhanced communication, especially in low visibility scenarios, is crucial. Training on interpreting radar targets without AIS signals, implementing AIS transmission, avoiding assumptions, and constant radar plotting in darkness or poor visibility are essential measures to prevent similar incidents. Now let's discuss some strategies to minimize these accidents and incidents. Fatigue management. Set rest schedules considering minimum and maximum work hours and rest required by maritime operations. Ensure crew members have enough time to rest and recuperate between shifts, especially for those traveling long distances to join the ship. Plan drills and routine maintenance tasks to minimize disruption to rest/sleep periods. Technological solutions. Utilize fatigue monitoring systems to identify crew members at risk of fatigue-related incidents. Modify work schedules and rest periods, based on data gathered from monitoring systems. Lessen crew members' workloads using automation technology to reduce incidents linked to fatigue. Training improvement. Integrate simulation and advanced training techniques into maritime training programs. Focus on non-technical skills, NTS, and crew resource management to enhance training effectiveness. Explore resilience engineering, to promote adaptability, flexibility, and safety in maritime operations through team training. Review training approaches to improve operational efficacy and safety in the maritime sector. Decision-making protocols. Emphasize sound decision-making skills in the high-stakes maritime environment. Establish critical decision-making protocols involving systematic information gathering and evaluation. Encourage logical reasoning, dedication to truth, awareness of contextual factors, and evaluation of multiple options. Foster independent decision-making aligned with crew objectives and know when to seek advice from others. Finally, we would like to present some recommendations. Prioritize ongoing training and education for your industry stakeholders. Incorporate advanced techniques and simulation to enhance both technical and non-technical skills. Implement robust fatigue management systems aligned with regulations and leveraging technology. Ensure the well-being and alertness of crew members through effective fatigue management. Establish clear decision-making protocols to promote transparency and continuous improvement. Use decision-making protocols as a foundation for effective navigation in routine operations and emergencies. Incorporate human performance considerations into risk-based ship design methodologies. Focus on global design factors in risk-based ship design for a proactive approach to safety at the design stage. Optimize collaboration between human operators and embedded intelligence systems. Ensure technology enhances efficiency and positively contributes to the capabilities of human maritime operators. Embrace recommendations with adaptability, industry-wide cooperation, and regulatory support. Lay the groundwork for fostering our resilient safety culture in maritime operations through these measures. That's all for this video. Thank you.